Okay, Eitan, the floor is all yours. Feel free to share your screen.
Thank you,
Start
Gene.
with your introduce yourself and start with your presentation.
Sure thing.
And thank you so much to all attendees.
Thanks, Gene.
You are very welcome, Eitan.
All right. So today, the topic of the day is advanced dynamic search queries and how to protect them. Let's see what I mean by that. But first, a few words about me. As Gene said, my name is Eitan Blumin. I'm a DBA team leader at Madeira Data Solutions located in Israel. We are basically the lead Microsoft data platform consulting company in Israel. We also basically manage and lead the local data platform community. You can find us at madeiradata.com. I also have my own personal blog at eitanblumin.com where I share technical blog posts about SQL Server and everything related to it. I'm also active on Twitter and also on LinkedIn and Facebook. You can just search for me. I'm sure you'll find it. You'll find me with quite ease. I'm a SQL Server DBA since the year 2005. As I said, I'm a DBA team leader and a solutions architect at Madeira Data Solutions, and I'm a data platform MVP since 2020. I also co-host a SQL Server Radio podcast since 2020, together with Guy Glanzer, also from Madeira Data Solutions. And that's all about me. Let's go ahead and dive in. Before we start, what you're about to see here is a bunch of stuff related to code, basically, T-SQL code. And everything I'm about to show you is available on github.com at /Madeiradata/dynamic filters. All code is open source and available, including the very presentation that you're seeing right now. First, we'll start with a story. This is a true story, which is the origin of my experience that led to what I am about to show you. So the story is this. The customer in question had something that looks like what you see on the screen. Basically, a table, a graphical interface of a table, which queries from the database based on specified filters. You could have like a one filter per column, and there will be something very basic behind the scenes, like a store procedure or parameters, ad hoc query with parameters that would use the input data to filter the results and return to the screen. Let's start with that. That's something which is a very basic use case, right? I'm sure that plenty of, if not all, of the viewers are familiar with this use case. So let's start with that as our basis and see what happens behind the scenes. So the common method, or maybe the most basic method, is what you see here. Let's say we have a table called members. And we have something like this, like the filters on name, on country, and registration date that would be affected by parameters specified by the application, by the business layer, basically. Something that looks like this would be eventually translated to T-SQL query that looks like this. This is what the SQL Server basically receives as a request from the application. If you have basics experience with SQL Server or RDBMS in general, you should know by now that this means SQL injection. That if this input comes from an end user, let's say from a search form, like the one you saw in the previous slide, then this means that they could input something here in the parameters that could be malicious and dangerous to the database. So the common solution to that is to parameterize your query. And instead of injecting scalar values, literal values, you would be using parameters. These parameters could come from the application layer, which would construct it as a parameterized query. And it would look differently. It would look like this. We don't have a danger of SQL injection here. This is quite fine. And this is quite common. Let's say we do something like that with optional parameters, right? So we have, let's say, a store procedure called search members that receives a set of optional parameters. Each of those parameters will be checked by the query whether it is null or not. And if it is not null, then it has to conform to some kind of search predicate. For example, name can either be null, which means I'm not filtering based on name, or it must be contained within the name column. Likewise, for the country parameter, either it can be null, which means I'm not filtering by country, or it must be equal to the country column. And similarly, the registration date form either has to be null, which means, again, I'm not filtering based on registration date form, or it has to be smaller or equal to the registration date column. Can you please mute the mic? Yeah.
I'm gonna take care of that and put everyone on. Everyone access.
Sure. Can you go ahead and mute that, please?
Yes, give me a second.
बोला कि छोटे चाचा आ जाए तो मुझे मैसेज करो व्हाट्सएप पे, मैं तुमको व्हाट्सएप पे कॉल करूँ। वो खत्म हो गया मिनट्स।
Thank you.
You should be good now.
Okay. So this is very common use case of basically implementing a set of optional search parameters for a query. Now the issue here, the biggest issue here would be parameter sniffing, which means that the store procedure is compiled once with a specific set of parameter values. Some of them might be equal to null, some of them might not at that point of compilation. And that whether they are null or not would affect the execution plan, which results from this query. Sometimes I would be searching by name and country and registration date form, but sometimes maybe I want to search only by country. And in that case, maybe using a predicate like this on name and registration date would have negative impact on the performance of the query because the execution plan would not be optimized for it. The common solution, or maybe the easiest solution for it, would be to add an option recompile clause at the end of the query. And what this would do is basically tell the SQL Server, okay, at this point, upon execution of this statement, I already have the values, the specific values for each of these parameters. And if I recompile this specific statement at runtime, then I would know the values, and based on those actual runtime values, the SQL Server could construct the best optimal execution plan for that query. So even if I write here name is null or name like something, but if during runtime name is actually null, the SQL Server engine could absolutely ignore this filter as if I didn't write it. That's the benefit of using option recompile. There are, of course, other disadvantages to using option recompile, such as basically it means that the execution plan is not cached. It is not saved in the cache, in the plan cache. And that also means that it has to be recompiled every single time the store procedure is executed. And that could have negative impact on CPU utilization and possibly query runtime. The common method to resolve that is to use dynamic SQL. And basically, instead of where name is null or whatever, I'm using a set of if statements. And based on those if statements, I dynamically construct the command. And if a parameter is not provided, it has null, then the predicate itself would not be part of the query. So the end result could look something like this. Maybe I filtered only on name, and that is how the end query would look like. Or maybe I filtered only on country and registration date from. Sorry. And each of these dynamic queries would be compiled separately, but it would also be saved in the plain cache. And basically, this would mean that each unique permutation of a query is what would be stored in the plain cache. So that's all well and good, but what they actually wanted, that customer in question, is to take it a step further and not just have a set of filters for a specific set of columns, but also be able to provide the end user with the option to dynamically add as many predicates as they wanted and with as any operator that they wanted, whether it be contains, not contains, starts with, ends with, equals, not equals, equals larger than, greater than, and so on. This sort of flexibility would not be possible using the basic method that we saw earlier, because now it's not just the columns that need to have parameters for them, but it's also the operators, like, equals, greater than, and so on. And that adds a level of complexity. Now, the limitations to the common methods that I outlined before, they come down basically to this. The number of parameters is limited. Maybe I could theoretically create a stop procedure with hundreds of optional parameters and use whatever algorithm that I want to optionally add one type or another of operators and filter predicates to the query. But obviously it will be complicated, and whatever hundreds of something parameters that I add, the stop procedure would be limited to that number. Also, the operator type per parameter either would be fixed or it will limited. So either each column would be limited to a specific operator type, as in the previous example, where name was limited to the like operator, country was limited to the equals operator, and so on. Or I would have to add in, like, I don't know, some kind of optional parameters for the operators themselves. And either way, it would be limited. And most crucially, any change in the metadata of the table of the query, whether it be a new column, which means I would have to add a new parameter, or maybe a set of parameters. Maybe I want to add a new operator type. And all of these changes would need to be done across all layers, basically, in the front end interface, in the business layer, and in the database store procedure. Let's try to really understand the problem about why these limitations exist. But first, a few definitions. Let's set ourselves a set of basic terms that we would use for the duration, for the remainder of this presentation, to help us comprehend the problem easier. So let's say literal values will be marked in red. Those are the literal values that would be coming from the end user, the ones they type on their keyboard. A parameter are basically the parameters themselves, the ones that start with the @ symbol, such as @name, @country, @registration date time from. A parameter collection would be a set of parameters. Okay, so let's put that aside and see an example. So if you recall the first example we had with the SQL injection, basically the literal values here are marked in red. Those are the values that come from the end user. The yellow markings here denote the parameters. So like a name is basically a parameter, a country is a parameter, registration date is a sort of a parameter. You're probably asking yourself, okay, where's the parameter collection here? Well, you can look at it this way. The parameter collection is the whole query. It contains inside itself a collection of parameters, and each of these parameters receives a literal value. Good? Okay. Let's take the other example of the store procedure with dynamic SQL. So in this case, we don't actually have literal values here that are used explicitly inside the store procedure because we use parameters. So this way we avoid the SQL injection problem. And each of these yellow lines is a separate parameter that if we need to change something in the parameter or add a new parameter or remove a parameter, we would have to maintain these yellow lines. And the store procedure itself is basically works as the parameter collection because it itself has the set of parameters, which is name, country, so on. Okay, so let's look at the layers of our system. We have the graphical interface where the end user enters their literal values, and something at the interface needs to call some kind of method, let's say, that takes each of these fields, the parameter fields, from the user and sends them over to the business layer. At the business layer, each of these fields that were sent from the graphical interface need to be sent as parameter values to the store procedure at the database level. And obviously at the database level, we have the store procedure itself, which also has the parameters. So here we have each of these sets of parameters works in itself separately as a separate collection of parameters. Okay, so let's think for a bit and see how do we solve the limitations? How do we solve these limitations using the knowledge that now we have? So the number of parameters is limited. The operator type per parameter, it's either fixed or it's limited. And adding a new column or a parameter or an operator requires a change in each of the three layers in the interface, the business layer, and the business logic, sorry, and the database. How do we solve it? So the solution that I suggest basically means adding another layer on top of everything else, which we'll call a layer of abstraction. Okay, so if until now the parameter collection and the parameters were basically they were expressed as code. Okay, they were maintained as code, and the literal values came from the end user. Now we add a new layer of abstraction. Let's call it the parameter parser. And once we have that, which encapsulate and abstracts everything below it. Now, the parameter collection and the parameters can be maintained as data instead of code. Now, our parameters are data-driven, and the only code involved here is the parameter parser, this layer of abstraction that I'm talking about. So let's add our little friend at the top here and see how this works. So now that we have another layer, all we have to do is maintain and transfer a collection of parameters and parameter values. Okay, so now we're not dealing with parameters anymore. We're dealing with a collection of parameters. So at the database level, as I said, the parameters and parameter collection, they're data-driven, right? So they sit at the database level, let's say in a table or a set of tables. They would be retrieved from the database and eventually find a way over to the graphical interface. And this would be our metadata. This is a data-driven metadata, okay? And it will look something like this. Let's assume that it is returned to the graphical, to the user interface as JSON, okay? It's basically in the JSON array where, let's say we have a collection of filter columns, okay? One of them is called name. It receives operators 1, 2, and 3. Another one is called country, which receives operators 1, 2, and 4. And it also has a list of values, Israel, USA, Italy, and so on. Also, we receive a set of filter operators, which correlate with the operators we see here, 1 to 3, 1 to 4. These are actually the filter operators that I'm referencing here. So we have equals, not equals, contains, in, and so on, and whether each one is a multi-value parameter or not. That would affect the way it is constructed dynamically by the user interface. So we have a parameter parser at the interface level that would take this collection and dynamically construct the search form. Working, constructing, and then we have something like that looks like this. Using JavaScript, doing something like this is fairly easy. Now the end user enters their literal values, and now we have a collection of parameter values or filters, let's say. Let's say the user entered column ID 1, it selected operator ID 1, and this is the value that they inputted. And similarly for another column, okay? This set of data finds its way to the database, and basically there shouldn't be a problem to send it as is to the database so that the database could handle the parsing. So we don't really need a parser engine at the business layer. Now, this is the set of data that the database received, and it has the metadata, right? The data-driven parameters and parameter collection, and the information about them. We have a list of columns. This is metadata in the database, right? We have a list of columns, which operators are supported by this column. And we have a set of operators where even the expression, the search expression of the operator is also data-driven. It is here saved as text, okay? And it works as some sort of template that we can use, and then use the replace function to replace, say, this placeholder with any one of these columns, and replace the parameter with, I'll show you soon, okay? So it combines the two sets of data that it has, the metadata of the parameters and the parameter value collection sent from the end user, and it can use that information to dynamically construct a SQL command. And this SQL command would receive something like this. You see this at params dot value, and this is an abstract. This is pseudocode, okay? This is not actually how you write this code in T-SQL. It doesn't act how it actually looks like. This is pseudocode, but the point I'm making here is that we have one parameter called params, and it will have a method or something, a way to deterministically access the value of each parameter value from the collection of parameter values provided by the end user. So let's say we have two filters here, two predicates, and one of them would be connected to an varchar column, right? Because we have the information, the metadata, and it will receive the value, this John value. It will receive the value into the local variable, and similarly, if we have, let's say, multi-value, okay, so we can declare a table variable and insert into it the values where the ID of the filter basically is 2, and then it would receive these two values, for example, okay? And then the query, the actual dynamic query that queries from the members tables in this case, would use this P1 as the filter for name and P2 as the filter for country, a multi-value filter for country. And the way we would execute something like this, let's say this is our parsed SQL, okay, it's here. All of this is the value that will be stored here in the parsed SQL. And then we can use sp execute SQL and send over the params collection of values, right? This is the same parameter here. Same one here, same one here, is the same collection. And also here, and it would be able to use it to retrieve the values. Now, this is another method which solves a problem here, which is similar to what I mentioned earlier about parameter sniffing, because in this case, we are declaring local variables, right? So if I use local variables in a query, I'm losing the ability of parameter sniffing, and SQL Server doesn't know how to utilize statistics and indexes to create an optimal execution plan here. So a solution for that would be to take this section here and push it down another level, so that instead of this, we would have another sp execute SQL that would receive this command as a parameter from outside, right? But it will have to create this section dynamically. Okay, this is the issue, because I needed here to be created dynamically. So this list of P1, comma P2, this needs to be created dynamically. So in this case, all of this is parsed SQL, right? This parameter here, and CMD here, this one, would be this query, okay? And CMD params would basically be the list of like P1 and P2, or maybe not necessarily P2 here, because P2 is a table, but it could be resolved. And as I say, this add params parameter would be the same value, I'm sorry, the same collection of parameter values delivered across all layers. And this collection parameter, we have a few requirements from it in order for it to work okay. First, it needs to function as a collection of values. So it needs to be able to hold somehow more than one value of something. Secondly, we need to be able to deterministically access each each record here, each item. Yeah, each item is a good good name for it, I guess. We need to be able to deterministically access each item in the collection, so that if I'm asking for ID equals 1 at one time and ID 2 at another time, no matter how I write it, ID 1 and ID 2 would be the same ID 1 and ID 2. So what I mean by that is that I should not have a use case where I'm asking for ID 2 and I'm accidentally receiving the value of ID 1. Okay, I hope that you follow me here. So in SQL Server, we actually have a few data types that can support this functionality. We can use XML, you can use JSON, we can even use table value parameters up to a certain extent. I guess we could also implement some kind of CLR user data type here, which do similar functionality, but personally, I don't think it's necessary. I think the other data types have more than enough functionality that to give us this solution that we need. Okay, so let's review so far what we had. On the left hand, with the abstraction layer, the graphical interface receives the metadata from the database and uses it to dynamically generate the search form. Okay, the next layer, the business layer, receives a single object of which is basically the parameter values, collection of parameter values from the interface and execute the stop procedure using a single parameter. The stop procedure uses this single parameter to parse it as to retrieve the list of parameters selected by the user and use it to generate the dynamic command that it needs. Without such an abstraction layer, what we have is an user interface which is hard-coded. We have a business layer which executes a stop procedure using multiple parameters, and again, it's also hard-coded. And we have the database stop procedure that possibly, maybe, could dynamically generate the SQL command based on hard-coded logic, based on hard-coded set of parameters. Okay, so let's see a demo in action. So the screenshot you saw earlier from the fully dynamic search application is actually a demo app that I made myself. Before I show it to you, just a small primer. I am not a professional web developer, so don't expect, top quality from it. I only did like the most basic stuff that I could, but it does what it needs to do, at least for the purpose of this demo. So, okay, so let's look at what we have. In a bit. Okay. So this is the demo web app that I have, and it is fully functional actually. I can use it to add new parameters. Let's say I want to filter on, let's say, username. Okay, and I want to select which predicate. I don't know, let's say contains, and the value will be XX. I add it to the list. Okay, and now I can pick a bit into how the collection of parameter values looks like on the graphical user interface side. So, okay, so this is in JavaScript, right? So, I mean, the interface is implemented using JavaScript. So this is actually the value underlying all of this. And let's say I want to edit something. Let's say this one. Okay, and we can see that it changed here, right? And I can add as many as I want here. Let's say I have country in Israel, USA, France. I could also filter on country. Let's say not equals USA. Okay. So this is how it looks like behind the scene. And once I click on search, you can see that we have the data that we requested. Okay, so this filter on username is not very, not very useful, but you get the idea. Also, I can, using the tooltip, using the tool, come on. You can't capture the tooltip. Okay, so I hope you see it well enough. So we have the list here. This is basically the raw data underlying this row that you're seeing. I could basically from the business layer, I received this JSON response. This is like the raw data, okay? And the user interface parses all of this into a table form, okay? Very basic. Now what I want to do is open up SQL Server Profiler and show you what happens behind the scenes. Let's say T-SQL. No. Yeah, should be good enough. Okay. Run. Okay, let's run it again. This is coming from report server. Where was it? There it is. Let's see what we got. So what happened here is that the business layer executed this stop procedure, and using this is the value that it sent to that. This is basically the params parameter, right? This is the collection of values. This is what came from the end user. And we have the parse_SQL returned as an output parameter. But we can also, you also select to run command, which basically tells this stop procedure, this is the parser stop procedure, to also execute this command. So let's see this in action. As you can see, this is the data retrieved. And also, this is the content of parsed SQL. Let's see how this looks like. This is the actual query generated dynamically by this parser stop procedure. Okay, as you can see, it uses JSON in this case and declares these parameters P5. All of these parameters. Okay, we have one parameter, another one, and so on. It uses JSON syntax to retrieve the values into each of these parameters, and then executes the query. Pretty cool, right? Another thing I want to show you is the metadata, this data-driven parameters and parameter collection, how it looks like on a database side. So we have, let's start from this one. We have first filter tables. I just only have one here that has some kind of alias that it needs to receive from here. Okay, so let's say the business layer needs to tell the stop procedure which table I am, or more properly, which table alias I'm querying from, and underlying that could be, let's say, a view. Okay, doesn't matter. I could have as many here as I want. Each of these tables has a set of columns, which says to which table alias it's connected, the real name of the column, its SQL data type, its display name, which basically means how it should look like at the interface, right? So first name, country, registration, and so on. This is what determines how it would be written. Whether I can, and I have all different kinds of set configurations here. So whether a sort is enabled, which operators are supported for this column, and if it's a multi-value, If it's a multi-value column, then I can also input here the query, which would be used for retrieving the list of possible values. Let's say, for example, country, whatever. So this is, for example, coming from here, country, it's this one, right? So this is what happens behind the scenes. In addition to columns and tables, we also have operators, which is the most important part. And here we have the list of operators, whether they are multi-value or not, how they are displayed, and the operator template, which basically means how the actual search is implemented. And using all of this data, this and this, sorry, not this, I mean this templates and these list of columns and list of tables if I have more than one, all of these together give me enough information that I can use to dynamically construct search queries. So using this methodology that I showed you, this data-driven methodology that I showed you, what have we achieved? Now, the number of conditions is unlimited. It doesn't matter. I mean, the user could input as many combinations as they want of filters, at least as per the limitation defined in the metadata. For example, let's say the list of columns here. So for example, operator 4 ends with, okay? Not 4, sorry, I meant 5, greater than, okay? So let's say username cannot use the greater than operator, which is okay, because that's how I defined it. We could also have multiple multiple operator types per parameter. And whenever we need to change something in the list, the set of parameters and operators, there's only one single point of maintenance, which is these metadata tables in the database. It's data, it's not code. It doesn't even require you to deploy a version. You don't need to deploy a new version to upload new DLLs or assemblies or whatever it is you need to make changes in your application. It doesn't even need that. Just insert a new row or change something in an existing row, and that's it. You're good to go. And despite all of the amazing flexibility that we get from all of this, SQL injection is not possible, because at no point we concatenate literal values entered by an end user. Obviously, there is SQL injection here using the metadata that we have from the metadata tables. We have to use that, but it is not data that it's coming from an end user. Okay, so it should be safe. Okay, so hopefully you like this solution. So what's your next step? Next step is to go to my GitHub repository. I'll put up the links again soon. You can download the sample project and review and study the store procedures responsible for parsing the filters, or you could build your own solution based on your understanding of this presentation, although I'm guessing you would prefer to have a better starting point. And next, you can go to your developers or product managers or team leaders or whatever and tell them you have a nice surprise for them, where you can now implement a very flexible search form for the end users. And the next step after that would be to start worrying, because now end users are going to will go wild and start querying all kinds of crazy permutations and possibly abuse your indexes and statistics and tables. But there are other ways to resolve that, and we'll leave that aside for now. As I said, the source code is available at github.com/metadata/dynamic filters. And now is a good time for questions.
Are there any questions? Guys, let me give you access to unmute yourself. Give me 1 second. In the meantime, Eitan, would you mind to show them feature data-driven community website? So
Yes,
this way, yeah.
definitely, very
Okay,
exciting.
perfect.
Okay, so we have the data-driven community here, and I want to click on it, please. Let me click on it. Thank you. Okay. There it is, September 29th. Go ahead and register. All the who and who's in the industry will be talking there, and I will be submitting also my own sessions over there. So you should go ahead and register right now.
Great, thank you. I think everyone have access to unmute themselves. Feel free to unmute yourself and start asking your question.
I don't have any questions. I just wanted to say thank you. I appreciate it. And I also wanted to say, oh my God, you're right with that last part of the slide with the atomic bomb because of the contains type things using the leading filters. And oh my God, that will never be searchable. I just, oh my.
Yeah, hopefully you have a very strong database engine for that. About that though, about that, that is an issue that comes up. It comes up frequently. So a few considerations for that. If you really do have this kind of need, this requirement to have this level of flexibility for your data, I think the most proper answer to that would be to consider actually non-relational database technologies for that. Maybe consider something like Elasticsearch or the Azure equivalent Gusto, what's it called, Data Explorer, or something of that sort, right? With there's all kinds of NoSQL solutions that work better for these specific scenarios. Obviously, they have their own advantages and disadvantages that we probably that's way beyond the scope of this session, right?
Right.
Absolutely.
Yeah, but so definitely. And another question that usually comes up in this session is how protected is it from outside abuse by end users? And let's say it's okay. No, this is not what I wanted. Yeah, this is what I wanted. So this set of values that comes from the user, this is basically the user input, okay? And any potential hacker, if they hack something, they would be hacking this. Okay. Now, thanks to the existence of metadata in your database, you would be able to basically how do I call it? Use it as sort of constraint on the data that you receive from the user. So for example, if instead of operator ID 1, they enter here drop table members, it wouldn't work because I am using this to join with this. Okay, so it's not using a dynamic query. It's used as a parameter for within join query. So these IDs and these IDs, they serve as a sort of constraint on the values that are received from the end user. Another point that is raised sometimes is that this parameter collection is a possible attack vector in the way that a potential hacker could inject a huge set of values in this parameter and just topple down the SQL Server just because it is so difficult for it to parse the enormous chunk of data that it just received.
So a bit of a denial of service type attack.
Exactly, yeah. So you can use something like that to create a denial of service attack. And the way to resolve that, it should be fairly easy. I mean, your business layer could serve as a sort of a guardian before it sends the data to the vulnerable database, right? It could simply check for the length. Just check for the data size of the parameter files that you just received. And if it's over a certain threshold, then show an error message and don't send it to the database.
Okay, I see somebody else has their hand raised, but let me ask one final question. Will this pass typical penetration testing software?
I believe it would, yes.
Okay. All right, I'll shut up now. Thanks, Eitan.
Actually, I enjoy your question, Jeffrey. It's Zach. Am I saying it right? Yeah, feel free to unmute yourself.
I am unmuted already. Can you hear me?
Yes. I can hear you.
Fantastic.
Yes.
Fantastic. Eitan, Alan, very good session.
Thank you.
I used a very similar approach. It was a kind
Wait, is this Isaac?
It's Itzhak Chabinsky, you know me.
Ah, how are you? I know you.
Okay.
The
Alan.
XML guy.
That's correct.
Yeah, I think we all know him, right?
I hope I can contribute to our session. I used in the past kind of similar approach, where the layers on top of the database they pass XML as a one single parameter, and the rest of the ideas were kind of very similar. The benefit of it was the following, exactly this question about the protection and everything else. The XML was enforced by the XSS schema.
Oh, yes, that's an excellent point.
And that's why it doesn't matter what they hack, what they put, if it doesn't pass the XSS validation, it is rejected by definition even before the start procedure gets executed.
Yes.
And this is amazing to see how it's happening. And obviously session is great, as an idea is fantastic, very useful, much needed everywhere.
Cool, thank you.
Thank you too.
That's an excellent point. So XML does have this capability of using XSD schemas to enforce constraint, enforce a specific structure to the data. We don't have that for JSON. So for that, this is a good example for why you would prefer to use XML instead of JSON. Yeah. Thank you.
Good question. Any other question?
Well, no, just a statement. I'm hardcore SQL, and so screw all that. Use stored procedures only.
Well, there is a stored procedure behind the scenes, you know.
That's a great debate, right? So, thanks again, Eitan.
Cool.
Yep. I think we all set for today, correct? No more questions. Eitan, may I ask you one question?
Go ahead.
How long did it take you to prepare this session? Because this is an outstanding session. I enjoy it.
It is actually one of the first sessions I ever prepared. It is years old.
Yeah, but that was
the use case in question, the real story, the true story that I mentioned, that happened in the year 2012. And the first time I created this session was a bit later that year, around 2013. And it went through several iterations and improvements over time. And I already delivered in several other meetups and other user groups. so I have some experience with it. You can say that, I guess.
Right. And you put them together very nice. Thank you so much. And it was an honor to have you here. Right. And thank you to all attendees. I hope you guys register for Feature Data-Driven and also register for our next session, right? And have a great evening, afternoon. See you next week. And one more time, thank you, Eitan. Bye.
Thank you, Gene, for having me.
Take care. Bye.
Thank
Bye.
you. Bye-bye.
Bye, Yitzhak.